quickly start with load balances. So load balances, why we need load balances to start with? What exactly is the use case for load balancer?
Effective use of bandwidth.
Yeah,
To manage
effective
the
use of
traffic.
bandwidth is fine, right? Yeah. So to throttle the traffic and bandwidth.
High availability.
Yeah, that is true. So for managing high availability situation.
And also scale up, scale down.
Correct. So in order to distribute the traffic and scale up, scale down, true.
For netting purpose.
Okay, for network address translation. Very good.
You can say load balancing within servers.
Yeah, that's the primary thing, right? The name itself says it's a load balancer, right? It is going to balance the load across different backend instances. Load balancing across or between the backend systems. If you have more than one systems acting as a cluster or acting as a group of system providing an application service, we are not only improving the high availability, definitely like we are increasing the high availability here. We are improving the availability of the services by adding more servers to a particular application. But in order to do that, we need to distribute the traffic that is coming in from the front end to back end. I'll mute your line. So yeah, so we see, for example, I've got an application. So this application is being accessed by application dot customer one customer xyz.com. Okay, so this is the application we are accessing. And for this application, if you have multiple servers providing the service like server 1, server 2, and server n, we have got multiple servers that are acting as a group of systems for this particular application. When the end user access this particular application, they will be accessing using a fully qualified domain name or a specific domain, right? When they hit this particular domain, their request should have to be passed on to backend systems, and it should also, the load balancer should also see which systems are currently having a lot of load and which systems are having least traffic. So there are some algorithms that also work in between, and the load balancer algorithm will make sure that it distributes the traffic to the specific system that is not being heavily used, right? So some algorithm, some load balancer will distribute the traffic in a round robin way. Some load balancer will distribute the traffic in a kind of least connection system. So it depends on load balancer, which load balancer we are talking about. So Azure also has got multiple load balancer option. Even you can use the native Azure load balancer, or you can go for third party KEMP, or you can go for some whatever load balancer is of your choice. Okay, so load balancer, primary purpose of the load balancer is to balance the load from the end users to the backend systems that is providing the application service. Okay, that is the main purpose of load balancer. It is going to deliver load balancing, number one, and it is also going to help you achieve high availability for your system. And as Bala highlighted, it also helps you to instantly add and decrease backend systems, right? Because like we have a group of systems here, and if there is a particular sales that is happening, or if there is a high year-end processing that is happening, which demands more systems to process the traffic, or if there is something that you are launching newly and there might be unusual request, so unusual number of requests, then you can go and add more servers for during that particular tenure. And after that, maybe after the year-end processing or after the sales is completed, you can go and reduce the number of systems. It helps you to instantly add and remove the servers on the back end. Okay, so in the load balancers, generally it can be used for public facing, meaning it can be used for internet facing users, the public users, whoever is on the public. So anyone is authorized to use Google, right? So anyone can go and okay, so it's open for general public. Or maybe there might be some specific sites which are only restricted for access from specific private organization. So it can be internal, which is like private only, private facing, or private, internal only. load balancers. So when it comes to these two categories, public load balancer and private load balancer, the public load balancers has to be carefully created and well thought deployment. The reason I say that, since the load balancer is getting exposed to internet, you should always have a closer watch on that. The reason I say that, there are chances this load balancer can allow traffic which is vulnerable to impact your environment. So always we might have to think about protecting it a little more further, either by disallowing some unwanted ports and the basic things, right? And on top of that, generally public load balancers in a larger organization, they would like to have some kind of application firewall or a web application firewall or some kind of protection, firewall protection in front of the load balancers. Okay, so always the public load balancer, whenever you create a public facing load balancer, you always have to discuss with your firewall team or network team and understand what kind of protection mechanisms we are going to have. But for the internal load balancer, we need not spend a lot of money to protect it. Rather, you can just try and safeguard at the network security group level or at the network level, whatever possible. You can try and limit the lateral movement of the traffic. But if you're exposing the load balancer, because load balancers operate at the layer 4, right? Everyone knows that. So in ISO OSI model, they are different layers, and this one operates at the transport layer, right? So a lot of data is getting transported at this particular layer. We have to be very careful when you deal with this is like the technology layer which you're talking about, right? ISO OSI, the application, presentation, session, transport, all those things, right? So this operates at the layer 4 in the ISO OSI model, and it helps you to distribute the network traffic across backend system. So distribute network traffic across the backend systems. The backend systems can be two systems. Like only when you have more than two or more systems, then comes the traffic distribution. If you have got only one server, then there is nothing called load balancing or distribution or whatever, right? So only when you have multiple systems on the backend, you have to go and do it. And this load balancer, people think it only distributes the traffic. It is not the only thing that it does. It also does natting, patting, and also it also does some kind of monitoring of the backend load. Okay, so it also does monitoring. When I say monitoring, which systems have got how many number of connections, or how much load the backend systems has got, which are the systems that are acting properly. It will also go and do a health probe, whether that machine is properly reporting back on that particular port number, or whether the machine is online. So all those kind of health probe, either at the TCP level or at the ICMP level, it will definitely go and do it. And this particular load balancer, it is mainly used for Azure virtual machines and primarily the cloud services in your Azure platform. Just give me a second. Okay, yeah. So load balances, people will ask about how the pricing is being measured. So whenever we talk about Azure load balancer pricing, so it is based on the amount of data that the load balancer processes. Okay, so amount of processed inbound and outbound data. Okay, and also number of load balancing rules that you configure. So whenever you go and configure more and more rules, you have to be very careful that it is going to add up additional cost for you. But the health probe, the backend system group creation, all those things, that isn't going to add any cost to you, but you have to be a little careful about this. So when it comes to a load balancer in Azure, as I told you, it can be either internet facing, or it can be private only, which is like internal only. And we also have other options which we need to kind of explore. There are two levels of licensing. So always, like in Azure, they use this term called stock keeping unit, which will help you to understand how much we are entitled to do, what kind of features we can enable, what kind of backend functionalities we have got. So all these things, like they categorize it as stock keeping unit. Think about stock keeping unit as a kind of different licensing options, or different options that you have to choose from. So in Azure Load Balancer, we have got two different options. Okay, so the first option is the basic SKU. or the basic load balancer, and the other load balancer is standard SKU, which is nothing but your advanced load balancer. So between these two options, you need to kind of understand what exactly are the differences and which one can be used for what purpose, right? So the basic load balancer, from the listing here, you can see that I'll just pick up the important point quickly and then I'll explain, go through one by one. If you look at the third point here, it supports only HTTP and TCP. And even on the security level, it does not have any kind of option to secure your traffic, or it doesn't have option to enable certificate or whatever, right? So basic load balancer, it does not support options for HTTPS, the secure way of connecting on the HTTP layer. So only standard load balancer support HTTPS. So by that comparison itself, it is very evident that you can use basic load balancer for proof of concept or testing or development activities. You can go and use basic load balancer or basic SKU type of load balancer, but standard SKU is what is preferred if you go to production environment. If you go to mission critical environment, definitely you need to go for standard SKU. The number one reason is the security is very less on the basic load balancer. The second important thing is this comes free of cost. Which one? The basic SKU is no charge. It is free of cost. Whereas the pricing for your standard load balancer, it is based on the number of rules and it is based on the amount of data it is going to process inbound and outbound between the resources, right? So it is primarily dependent on these two classification. So when something is free of charge, definitely there is no SLA, there is no service level agreement. But if you are paying for something, then definitely there is a service level agreement, so that the load balances are available to you as a service for a particular assured amount of time. When I say assured amount of time, 99.99% of the time, this load balancer will be available. At least the data path will be working to backend systems, right? So comparing the basic SKU and standard SKU, there are some limits also. For example, the basic SKU support only 100 backend systems. So as I told you here, I'm referring to the backend system here. So in a load balancer, you will have a front end. Front end is nothing but your the fully qualified domain name or the front end IP address or the front end. Okay, so or the application name of the application. So we have a front end and we also have a backend. Backend is generally a set of systems, a group of systems. That's why we call it as backend pool. So it's a group of servers or systems in the backend, okay, which will receive the actual traffic and respond to user request. So we have a front end, we have a backend pool, and also as I told you, we have got something called health probe. Health probe is something to go and check whether these systems are responding on a particular TCP port or an ICMP port, whether it is responding back on HTTP request, whether it is responding back on HTTPS request. So all those things will be validated and it will be stored in the monitoring log, so that if the new request comes in, it will not go and send the traffic to the system which is already not responding, or it is not properly answering to HTTPS request. So in advanced load balancer, standard load balancer, you also have option for HTTPS. In basic, you don't have that option, number one. And as I told you, like the standard SKU, it supports more backend systems. It supports up to 1,000 systems on the backend. So if you are using standard SKU, you can go up to 1,000 instances. But if you are using your own custom image, last week we discussed about how to create a image in Azure and use that for subsequent deployment, right? If you are using your own custom image, you can only create up to 600 instances. That itself is a huge number. Okay, 600 is a huge number. But if you're going, if you are using your custom AMI or a custom image, make sure you understand that it doesn't support up to 1,000, but it supports up to 600 VMs. So the backend system, the backend systems which you're talking about, it can be two systems as a standalone system, or it can be combined together into a virtual machine scale set, meaning it can be also combined together as a auto scaling group. Automatically, based on the increase in load, it will add more servers. Automatically, when there is a load decrease, automatically it will reduce the system also. So your backend can be either a static set of systems or it can be a dynamic set of systems, where based on the load, it will automatically increase the number of systems and decrease the number of systems. We'll go and see the practical little later, but yeah, so it also supports either static grouping or dynamic grouping on the backend. And the very important option is availability zone. When you talk about redundancy, see the backend systems, if you are having everything on only one data center, only one availability zone, what will happen if that particular availability zone goes down? Availability zone is nothing but a specific single data center or a physical data center. If this data center goes down, then all the systems in that data center will be impacted, right? So in basic SKU, you don't have the option to load balance the traffic across availability zone. So all the machines should have to be in the same data center in basic SKU. In standard SKU, you can distribute traffic across different availability zones. Okay, so people will ask, how about distributing traffic across region? So across regions, I'll help you. There are other options like traffic manager and DNS based load balancing and so on, which we'll discuss a little later. But if you want to distribute the traffic across different availability zone, then you need to have standard SKU load balances. Okay, so that is something which you need to keep in mind. Then comes the diagnostics. Diagnostics, only very few diagnosis information are provided in basic SKU. Like it will tell you like whether there is an exhaustion of usage, whether there is a backend systems, number of systems is going down, or if you want to get some additional information like how many bytes are transfers, how many packet are being connected, or how much active data plane is going on. So advanced level of diagnosis is available on standard SKU. Okay, so you don't get detailed information on basic, but in standard SKU, you get the detailed amount of diagnostics information. And the HA port, so it also supports internal load balancing, and it also supports public IP based load balancing. Which one? The standard SKU. And also it is secured by default. The security is at its best in standard SKU, but in basic SKU, by default, the load balancer itself is open to all traffic, and the NSG is an optional thing in basic SKU. But in standard SKU, it is secure by default, and it also have the limitation in terms of what ports are allowed and protocols are allowed at the network security group level. And the next important areas are like the outbound connections. Okay, for example, if you want to do some inbound netting, outbound netting, if you want to do source netting, dynamic netting, all these options are supported only in standard SKU. I'll show you practical things on how netting, patting, all those things work. Okay, so that is again an important aspect. The next one is the TCP reset on idle session. So for example, in basic SKU, there is nothing called reset. For example, if someone is connected to your application and they are not actively using it, it will stay connected forever. It will be there in the customer time to leave, as well as on the catching, it will be still there. But here, there is a TTL in standard SKU, how much time the session can prevail, or how much time the connections can be made available. There is a time to reset actually. Okay, there is a time to leave at the TCP level. And here we can also have multiple front ends, inbound and outbound. And here the basic SKU, it supports only inbound traffic. It does not support anything on the reverse traffic. Okay, and for doing anything on standard SKU, if you go and make some configuration changes, the changes will be very quick because the orchestrator has a higher precedence for standard SKU. But if you do some changes on the basic SKU, since it is mainly used for POC and test environment, it takes more time. Okay, but 1.5 minutes is not a big thing, but here it takes only 30 seconds, right? And these 2 points we already discussed. There is no SLA and cost for basic, but whereas here we pay and we get the best SLA here. Okay, any questions from anyone? This is very important to understand from exam standpoint. What are the differences between basic and standard? In a nutshell, if you're going and deploying something for a proof of concept or for a testing or development, you can definitely save some cost by using basic load balancer. But if you're doing the same thing for a production or a mission critical environment, the minimum thing that you should recommend is the standard SKU because of the security nature, because of the advanced features and diagnostics it provides. Okay, So any questions from anyone on the comparison between basic and standard load balancers? Okay. Can one of you confirm I'm audible still and things are, you're able to follow me?
Yeah, yes,
Stan,
Dan,
just
we are
question.
following you.
Perfect.
You talked about the availability zones, right? So which means this is only between the zones, or standard
Yeah.
SKU can also have between the regions as well.
Okay, so now there is a option to do it, but it's more of a thing which came into a usage preview recently. But earlier, if you ask me the same question few months back, if you want to distribute the traffic across region, then you have to go for Azure Traffic Manager or Azure DNS based load balancing concept. If you want to distribute the traffic across region, so load balancer is generally an entity which is limited to or which is bound to a region only. Okay, it can distribute only traffic to specific systems in that same region. But now in the recent past, there has been preview and options are kind of getting added up. But most of the customers, if you ask me, they have deployed either DNS based load balancing or third party KEMP or third party checkpoint firewall or third party Azure traffic manager. There is a solution from Azure across region which is called Azure traffic manager. We'll see that in practical also here. Okay, so one good thing, see, for example, if you are a person who is focusing on a specific area like networking or compute or whatever, right? There are two things that you can do. Okay, if you're an architect or if you're a pre-sales guy, you can do two things. The number one thing, you can go and subscribe to the Azure latest update feed. Okay, so there is a Azure latest update feed where you can go and get you can go and enable the RSS feed and you can subscribe to that particular feed so that you are getting notified on whatever is getting generally available. For example, if they are adding something to their GitHub repository, if they are adding something to their Bastion service or whatever, right? So whatever new things that are getting added up, you can go and select which one is of your interest. For example, I am interested in compute, network, and some specific areas which my customers are using. I can select that and I can just get to understand what are the different things that are getting released on a weekly basis or a daily basis. Okay, so that you are providing the latest update to the customer. So number one thing is you need to kind of subscribe to the updates from Microsoft so that you provide the latest news to the customer, because like as a sales architect, as a pre-sales solution architect, you might be dealing with a lot of customer opportunities. You should not go and convey something little old, and cloud is evolving very quickly, and they will release features on a weekly basis, because on the back end the cloud development happens like a agile practice, or they follow some kind of scrum mechanisms to release new features very often. Okay, so which means there are a lot of changes happening, so you need to stay updated, and you subscribe for the updates, and just enable RSS feed to your email address or your like if you have a kind of GitHub account, or if you have some specific account, you can enable and get those feed. And the other thing that you can do is, if you want to stay ahead in the market, or if you want to kind of provide some options or roadmap to your customers, this is mainly from a pre-sales architect, mainly from a sales architect or a solution architect. Since the question came from a senior person, I'm just giving these input. Okay, you can go and check for preview features. Okay, in this preview features, it will give you a lot of new services or solution or pre-release options that are coming in. Okay, for example, if I want to explore a new feature like Azure Express Route Direct, I can go and enable it. And if I want to explore trusted VM backup option, I can go and enable it. So for this, you have to go and select it, and I have to go and register it here. So when I enable this feature, it is a pre-release feature. It doesn't have any SLA or whatever, but it is going to be available in the platform in next few months. The reason I say next few months, see, Azure has got a release date of certain services in 2018 or 2019 or 2021. Not all the services come alive very immediate. I mean, not all the services will come alive immediately, because there might be a lot of bugs or a lot of things that goes on the back end. So all these are projects which are currently in pipeline, and Microsoft is working towards it. And if you want to just specifically look out for something on the network or something on the security or something on the compute, you can go and filter down, and you can just look at what are the different things that Microsoft is currently trying to do, whether they are trying to give us a live migration option or they are trying to give us force delete option. What are the new features that are currently in pipeline? Okay, so that you can stay ahead of the competition, and you can also tell the customers that these are the things that it is coming, and you can keep the customers informed, and they will also be happy that they are working with a architect who is well informed about the new features updates that is happening. Okay, so that is what they are expecting, right? All the customers, you might have a weekly connect with them, and during that weekly connect you can tell them, so this is what we are using, and there is a problem on this particular layer, and in the near future we are going to get something which can help us overcome this challenge, or that kind of conversation is what customers are expecting. Okay, in order to stay ahead, go and enable this preview features and test out, and also go and subscribe for the updates so that you get to understand what are the new things that are getting released. Okay, the reason I told that, Ganesh, today I might give you an answer which might be on date today, but next week if you talk to the customer in cloud, it might not be the same. Right, so that's the reason I told you that two important points. So you always have to think about cloud as a evolving thing. You can say like based on the current understanding or based on the current situation, this is the thing, and in the future it might change, or it might drastically come up with new features or new functionalities. And also always if you want to have some clarity, talk to Azure support agent and get more details, because like some features they have dropped also in the past. Okay, they will try a lot of things, and then at the end they will feel like, oh no, this cannot be achievable, and they have closed some features also in the past. Okay, after customers,
Okay, Stan.
I mean, yeah.
Yeah.
So in AWS, we call it as service beta program. Okay, so we call it as service beta evaluation or service beta program, where the customers, or what we call the organizations like IBM or TCS or DXC or whatever, they get an opportunities. They are all partners, right? They are all service provider. They get the option to go and evaluate certain new features and functionalities in the service beta program. So in AWS, it is a little different way of evaluating, but here we get the option to go and select the preview features. We can opt in and opt out based on our customer requirement. Okay. Yeah, and also you can show it as a POC to the customer also. That's the one more advantage that you have in the preview feature, so that customer also feels happy that they have something which can be implemented in the immediate features. Even they can also, if there is a budget involved, they can also be ready with the budget, because not all the features comes for free, right? If you talk about security and other aspects, maybe we need to also understand how much it might cost, and how it is going to improve your customer environment and so on. So if you want to enable the Microsoft Defender for the integration between your Azure platform and the GitHub repository, then definitely it is going to incur cost. It is going to add up cost for you. So anyways, so that's the thing. And even see, if you are talking to a customer, you can tell them there is a new feature that is coming in from Microsoft, which is going to help us manage multiple cloud. Okay, so multi-cloud management tool, multi-cloud preview. So these are something you can just help them understand that by choosing Azure, they are not just helping you to manage only Azure platform. Even you can go and manage other cloud platform from Azure console in the near future. So those kind of things will make customers feel a little interesting, and they might choose because I had a lot of conversation with the customers. They want to have one cloud platform to manage all the different private and public cloud and other environments, right? So those kind of options are well thought by Microsoft, and they are coming up with a lot of options like Azure Arc, which is already almost customers are starting to use, and this multi-cloud option, this is also a very good option. So a lot of things are evolving, a lot of things are coming in the pipeline. Okay, so getting back to our topic here, the load balancer topic. So load balancers are mainly for achieving high availability, or for getting your services available for the end users by having backend systems, by having a group of backend systems, and by distributing the traffic to the backend system. And it also provides you resiliency when there is a disaster on one data center, or if there is a system maintenance that you need to perform on one data center or one server or one storage, and if there is an unusual spike in the traffic, or if there is a malicious attack that is going on in a particular location or a data center, this load balancer will help you to bring down the system's individual.
Stanley, we lost you actually.
Unable to hear you, Stan.
Yeah, I'm sorry, team. Okay, there is unusual power disconnects in the last couple of days. I don't know, like there is some maintenance activity going on in my area. There might be some, uh, I mean, it's going on and off. But anyways, I'm back on the network now. Okay, there was a brief power disconnect. Okay, so here load balancers are primarily useful for overcoming the downtime. So if you talk about multiple servers here, all these servers have to be patched in a recurrent way, or they have to be patched in different intervals. So if you have patching schedule, if you have some 5 servers, you can patch each of the server in different weekends or different time, so that you don't bring all the systems down. So this is not about distributing traffic on the backend. It also helps you to bring down the systems as part of your patching activity or planned or maintenance window or whatever you want to do. You can actually do it in a phased manner, so that your systems are taken down into maintenance in a phased manner, so that there is no impact to the application. So load balancer is mainly to distribute the traffic, and very important thing that you need to understand is there are these different components. You have got a front end, you have got a back end, you have got a rule that will help you to configure which request has to go to which backend systems and so on. I'll show you those things in practical. Okay, so let's see those things in practical now. And let me go and show that. And before that, let me see
Stan,
if there is any other. Go ahead.
regarding that virtual machine scale state auto scaling, you told that we have dynamic and static, right?
Hmm.
If it is dynamic, it will be automatically increase and decrease. If it is
Correct.
static, in the sense how that it will be
You have
function.
to add more servers and delete the servers manually.
Oh, okay.
I'll show you how to do that. So you have to manually manage the backend systems. If it is a dynamic auto scaling group on the backend, it will increase and decrease the load. So that is the best way. But the other thing is you cannot have control on the cost.
Okay, in
Okay.
which scenario we will go for static?
So that's what I'm
Is it?
telling, right? So if customer is very keen on cost, they will they want to limit the number of servers on the back end, and they want to keep a tap on how many servers are getting created and deleted, so that they don't end up. See, there might be certain cases if there is a unusual traffic suddenly because of legitimate traffic or illegitimate traffic, maybe some malware or something is hitting your machines. There might be some robots or some bots that can also be written to hit your backend systems, right? So in such
Yeah.
cases, the traffic will enormously increase, and the auto scaling will go and add more servers in such cases, and the cost
Okay.
might erroneously increase. Is there a
Yeah.
backend
Okay.
noise, team?
From my
Is
side,
there,
sorry.
no. From my side, is there any background noise?
No, Stan. Voice
Okay,
is clear.
okay.
Okay, Stan.
Okay.
Start.
Yeah.
Yeah. See,
Go ahead,
actually, when
Mahesh.
you mention like the external load balancer can be configured, whether it could be a software or the hardware load balancer. So whatever you mentioned the features, it belongs to the software-based load balancer or the physical one.
Okay, so 1 second, Ganesh. Okay, hopefully the election will end this week and I'll be free from this noise. So to answer your question, you also have a lot of load balancer option in the marketplace. So in cloud, it's all virtual appliances. There is nothing called physical options as of now. So it's all software load balancers, either the load master or Ishlangu or Kemp or whatever, the global server load balancer. So these are all software based load balancers. Okay, there is nothing called physical load balancer that is made available in the cloud as of now. Maybe the future might be different, but as on date, you can go and choose the native load balancer from Microsoft Azure, or you can go and choose something from the marketplace. So today we are going to start with this load balancer, but in the next upcoming classes, when you go and discuss the app services and all those things, we'll discuss the traffic manager, friend door, and application gateway. There are 4 options of load balancing services, even within Azure inbuilt options. Okay, and if you're asking me about the other options, there are hundreds of solutions that are available in the marketplace. Is your question different
Okay.
or
Yeah. Yeah. Correct. But is it, yeah? So when you mention like the external one, so the external factors are belongs to the only the software based load balancer, not the physical ones.
Meaning, can you come again with your question?
See, actually, you mentioned like we have an option to choose the external load balancers. The external load
Okay.
balancer
So
means
no,
which
here
is belongs to.
here like when I go to create the load balancer, the very basic option that I get on the first screen itself, whether you want to use it public facing or internal facing. So it's a sub option within your load balancer creation type.
Okay. Okay. Okay.
So
Yeah.
whether you want to expose this load balancer for public facing users or internal customers through a VPN or within Azure platform. Got it, right?
Yeah. Okay. Yeah. Okay.
Okay. Yeah. So this type is more into the LB type. Within your load balancer, there are 2 types you can configure. I think I took your question in another way and started explaining a little more other areas. But anyways, fine. So there are 2 options like public facing and internal facing. So these are the 2 things. Okay. So anyways, any other questions from anyone before we get into the practical aspect? There is one more important point called
Yes.
5-tuple algorithm. Go ahead.
Yes, Stan. You said that lots of available in marketplace, right? Does it comes under Microsoft support or it's a separate one?
Case to case. So certain load balancers, Microsoft Azure support also has some specialized team to support. See, for example, this is one important thing that you need to understand, right? If you go and create some servers like Ubuntu and all those things, Microsoft also has some internal support group called Microsoft Ubuntu Advantage Support Group or whatever, that they are all part of Microsoft Azure support only. But they support Linux operating systems and all those things. Similarly, certain services, they have some specialized group within Azure support group. They can support you to some extent. But if you're talking about checkpoint or if you're talking about something load master or which is completely owned and the kernel is managed by a third party, if there is a level of support that is needed from the third party provider, then it gets escalated to third party provider. Otherwise, Microsoft Azure support will try and help you to some extent.
Thank you. The one more
Yeah.
question is the appliances.
Yeah.
So you mean that physical devices are coming nowadays converted into appliances? Or am I
True.
correct?
See, all the people they have started giving you virtual appliances. So earlier, if you want to explore Checkpoint, you go and purchase it. Right now, if you want to have Checkpoint in the cloud, you can go and have the Cloud Guard or the whatever the solution that you want, like Checkpoint Sentinel services. Everything is now available as a software as a service. Yeah, they are giving you appliance option. Everything has been converted into a virtual appliance. Now it's all software driven.
Yeah.
If they're just
Thank you,
giving
Stan.
you hardware, it cannot sustain for long, right?
Okay.
Now customers are
Okay.
moving towards cloud and all virtual things. So definitely you have to get the option of appliances, yeah, software. So
Yeah. Thank
let's
you,
go
Stan.
and one point I started talking within, yeah. So 5-tuple algorithm, right? 5-tuple algorithm is nothing but when there is a traffic that you are evaluating. There are different load balancers which operates in a different way. So some load balancers will go and check only source IP, destination IP, and destination port. And if these things are open and these things are kind of accepted, it will go and allow the traffic. But some load balancers, it will go and check all the 5 different aspects that are possible, meaning, so it will go and check the source port, it will check the destination IP, it will check the source port, it will check the destination port and the protocol. So Azure load balancers, they distribute the traffic, incoming traffic will be distributed based on 5 tuple algorithm, meaning it checks all the 5 different hashes in the particular packet. It will check the source IP, it will check the destination IP, it will check the source port, destination port, and the protocol. Okay, some algorithm, some load balancer, it might check only 3 different combinations or 2 different combination, and it will allow the traffic. Okay, something will just check source IP and destination IP, and it will send. Some load balancer will check only source port, destination port, and protocol, and it will allow. But Azure load balancer, they check all the 5 different aspects before it evaluates and sends the traffic. So it also helps in a lot in some other options or features also. I'll tell you like how it helps you in terms of getting some more features enabled for you. Okay, so if someone asks you like it helps you with source IP, destination IP, it will check the traffic, whether this is allowed, whether the source port is allowed, whether the destination port is allowed, and whether this port and protocol is allowed. So Azure Load Balancer, it evaluates 5 different hashes. So it's a 5 tuple hash algorithm where it will check all these different things before it sends the traffic to the backend server or system. Okay, so now let's go and create a system resource group here. So let me go and add this, and let me go and say this is a happy load balancer, happy web load balancer 1. And so this is where you have to be a little careful. So whether you want to go for a standard SKU type. So for all production workload, Microsoft is clearly recommending this. So for any production workload, always choose standard. For any testing, POC, or development, then you can go and choose the basic workload for training. And if you want to save some cost, you can select basic SKU. And this is the next tier, whether you want to go for public or private load balancer. So for Ganesh question, this is what the important thing is. Now they have added an option called tier, where you can go and select whether your systems are going to be present within the region, or whether you want to have the systems across the region. Earlier, Microsoft supports the load balancer to function as a regional load balancer, meaning it can distribute traffic only within the region into multiple availability zone. But now they have given you option to either go by region or global. If you're going by region, then all the backend system has to be in the same East US location or Central India location or whatever. If your backend systems are scattered across multiple locations, then you need to go and choose the global tier option. Okay, so now here I'm going to choose the front-end IP. Front-end IP is where the end users is going to access. So as I told you, you will have a front-end, you will have some back-end systems. So now I have to go and give a front-end IP address for this particular load balancer. And I can go and purchase a public IP if it is internet facing. Okay, I'll say this is my happy load balancer front-end IP1. And I can go and choose if there is any free IPs here. Okay, or else I can go and create a new public IP address. I will say I want to have happy public IP. So happy load balancer public IP 1. So if you want to have your backend systems across zone, then you can select zone redundant, so that your backend systems are redundant across your zone redundant public IP. This is for your front end. And also you can have the routing option. Routing option meaning whether the traffic has to stay within Microsoft backbone, or whether you want to use the internet. If you are choosing internet, then you have to pay for the internet for all the data that is traversing or processing. But if you're choosing Microsoft Backbone, then the traffic will be, yesterday we talked about that, right? What is the advantage of going with Microsoft Backbone? You'll get more bandwidth, you'll get better speed and all those things. And I can just click add. Okay, so now on the next screen, you go and add the list of backend systems. Which are the systems that I want to go and load balance? So I can just add my existing servers. Let me just say this is happy backend pool 1. Okay, I can just select the different network that I've got. I'll select the happy virtual network. And I can add the systems that are part of my virtual network. For example, these are the systems that are there. Oh, okay, so what happened to my web server? So my web server is also there, it's running. Okay. Maybe it is having a basic SKU type. Let me quickly check something here. Okay, it's all on. Settings is fine. Oh, it has got a static IP. I'll change it to dynamic because of some experiment we gave all these things. Okay, but anyways, I'll for now I'll add one server here. You can add all the servers at the time of adding your load balancer for your backend, or you can also go and add additional systems after you are done with it. So this is the answer that someone asked, right? If you're going and adding virtual machines individually, then that option is called static grouping option. Okay, or if you are selecting the availability say, sorry, the virtual machine scale set or the auto scaling option. This is dynamic grouping.
Thank you. Thank you.
So dynamic grouping. So you can either go for static grouping or dynamic grouping. I'll show you how to do the dynamic grouping shortly. So we don't have the VMSS created, but I'll show you the lab how to do that. Okay, so the next screen, I can just go and, if you want to add additional backend systems, you can keep adding it. And the next screen, you are getting option to create the rules. Okay, rules is to restrict the traffic, like which port you need to allow, or which systems should receive the traffic, which system should not receive. So all such rules can be entered here. So this is to manage the incoming traffic to the backend systems, and to verify, to mention which systems are eligible or which systems should not receive traffic. All those things can be mentioned in this rule. I'll show you how to create some rules and explore this little more today. Okay, and next we go to the outbound. Outbound is again source natting. I'll explain what exactly is SNAT, DNAT and all. Okay, don't worry. This is for outbound. Okay, I'll explain it shortly, and let's review and create it for now. Okay, let's give it a minute. Okay, validation is passed. Let's say create.
Stan, I have one more question.
Yeah, please go ahead.
Regarding that load balancer, we can use only in virtual machines or app services, like if you
Yeah, you can use it for see, there are a lot of different solutions, right? When you talk about load balancer as a sub option within load balancer, then it is restricted to be used with virtual machines and scale sets and so on. But we have got 3 other load balancers, right? Traffic manager is there, application gateway is there, we have got front end, we have got the front door. So those things can be used for different services. Okay, it says deployment fail, and at least one resource deployment placed in the game. So let's say there are error. Yeah, answer is Azure load balancers support all the different things, but it is actually you have to use a different solution. Okay, it says NIC update. Oh, there is a conflict. I don't know. Happy app server NIC 2. Okay. So what we did is, while we tried creating it, we went ahead and created a separate network card yesterday, right, for the happy app server NIC. So that is actually creating a problem. So I'll just go and delete it, or maybe possibly disassociate it if it does not allow deleting. It will not allow. And let me just go and power off the VM, and it is creating a conflict. So these kind of things we need to be very careful. So when I go and add something statically and start handling it, you have to be very careful. What is the IP? Okay, 2.222. Okay, let me stop this and remove that unnecessary network interface. Okay, while we do this, any idea like what exactly is all about SNAT, DNAT?
So, you mean static NAT and dynamic NAT, right?
Correct. Yeah. Source NAT,
So,
DNAT, or static or dynamic, whatever. Yeah.
to my understanding, static NAT is we define the NATing. That means whenever there is a source IP coming in, outgoing IP should reflect in only within this range, or only this IP it has to show outside. Whereas in the dynamic NAT, the system itself design or show some IP randomly. That is what my understanding.
Okay. So here we are slightly talking about little different concept. Maybe whatever you said is right, but that is for static and dynamic. Whereas here we are talking about which is something called source NAT and DNAT. Let me mute your line and I'll explain that quickly. This is important to understand, especially when we talk about load balancers. So source NAT, and from the name itself, it will help you to distinguish it. You are using it, we are using it on a regular basis, but we don't know where exactly it is happening or how exactly it is being used. Okay. See, for example, source NAT. It is generally used for changing private IP or port into a public address. So this is mainly to convert private to public IP. Meaning, for example, you have a server 1 or you have a system user who is connecting from a desktop, and when they go and access the internet, generally how we do in the environment, we have a kind of network firewall device, or we in some smaller or mid-sized organization, they might have a squid proxy server, or like it might be a proxy server or a IAS server or whatever, right? So they might have some intermediate system that will help us to filter which particular URL I can hit, or which particular internet site I can hit, or I can go via the internet gateway. There might be a lot of devices which can act as an internet gateway. It can be a network appliance, or it can be a physical appliance, or it can be a software appliance, where it will decide what IP address I can hit and what systems I can hit. So if someone, for example, I will say xyz.com. If I'm going and looking at this xyz.com log, I will not see all these system IP address, but it will say all these requests has come from this particular public IP. So this particular firewall device or this particular appliance, it will convert the incoming private IP, and it will modify the header and footer, and the traffic will be translated just like the traffic is originating from this device. Okay, it translates the source IP address, and it helps you to access the internet size using this particular public interface. Okay, it changes the private IP address of the machine, and it will help you to access the internet site using private to public conversion. So here it translates the source IP. That is what source NAT is all about. It is used to change the source address of the packet. It changes the header and footer or whatever on the changes source address of packet. Okay, so this is the maybe like it can work on both TCP and UDP. It supports both headers. Okay, in general, it allows multiple hosts on the inside to access the internet as one particular IP. That's the general use case. Okay, I will capture it as an example. Allows multiple systems or hosts on inside to access internet or outside. Okay, so here when the NATing will be performed, the SNAT will be performed. The SNAT will be performed only after the internal filtering or routing is happening. The routing can be done on the L3 switch or it can be done on the router, but the SNAT is generally performed after the routing decision is made. Okay, it is performed after filtering or routing decision is made on the L3 switch or the routers. Okay, so if in this case the destination IP is maintained and the source IP address is getting changed. So in the packet, only the destination IP will be, only the public IP will be monitored. So the client inside LAN is not at all getting exposed. Okay, so here the client internal LAN IP is not getting exposed. So the other opposite.
Proxy,
Hmm?
sorry. So
Yeah,
proxy, earlier it was the
yeah.
one that we used to do it, right?
Correct. The
Okay.
proxy is the general one that we used to have, the Squid proxy or
Mm,
ISA server in
yeah.
Microsoft or
Yes.
IaaS or whatever, right? Yeah. So so the next one is the destination NAT or the DNAT. DNAT concept is just opposite to it. For example, if you look at Microsoft Virtual Machine, how we are accessing it. So we are connecting to public IP and it is translating to private IP of the VM. That is how we are accessing it, right? So when we access the VM here, we go and pick up the public IP and we access it. And on the backend, it goes and connects to the private IP of that system. Okay, that's what has been happening, right? So I'll detach this network interface. And so this is the public to private. Just example, I showed you, right? The virtual machine connection, or if you want to access some website, see, I'm hosting a website on a private VM here. And the load balancer generally acts as a DNAT option by default. So it will receive the traffic and the load balancer might have the public IP here, and the request will hit the public IP and the load balancer will distribute the traffic to the private IP on the backend systems. Okay, it translates the IP address of the internal servers and it protects the private IP is protected, but on the other end, the companies only public IPs are getting exposed. It's not the backend systems. The backend systems IPs are not at all known to anyone. Okay, so here again, the decision is made before the routing decision is made. The load balancer or the routing device actually makes the decision after the DNAT. Okay, so that's the other important thing. So it is performed before routing decision is made, because we don't know which system we are going to connect it, but still the DNAT will happen prior to that, before that. Okay, so the public to private conversion. So maybe a lot of organization are using web access firewall, or they are using some network firewall, which will do all these decision making and so on before even we allow the systems or allow the website to be accessed from outside to inside. Okay, this is the outside to inside concept. I don't want to get too much into it, but you need to understand these things, okay? Because the more you start exploring load balances, you need to understand those two aspects, especially the source NAT and the DNAT. So now you guys are clear, right? As the name suggests, source NAT is translating the source IP address. Generally, it will. That's what we captured here, right? Or did I capture something? Yeah, it is Okay, yeah, here it is, right? It translates the source IP address, and when connecting from private to public, and it maps the source client IP in a request to a translation that is defined in any firewall or proxy or whatever. And the DNAT is the opposite of it. It is the technique that is used for translating the destination IP, accessing the internal systems, and it's the other way around. Clear? Any questions from anyone?
Any classic example for source NAT or any practical example for source NAT?
That's what I told you here, right? Even Bala reiterated this. We have some squid proxy systems in your on-premises environment where all the users will get connected to the internet, and internet will only see the squid proxy IP. It will not see the internal systems IP. And similarly, the network firewall, when there is a big IP or when there is a checkpoint firewall, the external systems will only see the public IP interface here. So this is where the public IPs are configured, right? On the checkpoint firewall or on the proxy systems. So these systems will have only private IP. All these systems will not have public IP, but still it will be able to access the public internet sites using the internet gateway or proxy systems or network firewall or big IP or whatever system, right? That is the classic example of source NATing.
Okay, Stan.
Yeah. So DNAT is generally performed on the DMZ layer. Okay, so we might have a demilitarized zone where you will have a lot of public facing websites and so on, so that you actually have a secure. Okay, there is one. There is one site I can just tell you. It's called Tutorials Point or something. There exactly you get a lot of more details. Anyways. But generally NAT is, right? NAT is network address translation. So you are translating either public to private or private to public. So it converts one type of IP address to another type of IP address, or one type of network to another type of network, either private to public network or public to private network. It's the conversion. Okay, it's the way of handling the packets, or it's the way of transmitting the network. So here I'll just go and delete the network interface, which is creating conflict. So when you are adding it to the load balancer, we need to kind of make sure that the conflicts are, you should not have more than one network card using the same IP, and the service also will get impacted, right? So if you want to configure different websites for different IP address, you know how to do it on the IP binding, right? With either in the Apache or IAS, you have the concept called IP binding, where if you have multiple web links, you can go and bind it to different port address. Let me refresh and let me try to redeploy. Okay, so let's see if this time it works fine. I don't have to go and do it from the scratch. Instead, I can just select the resource group and region and try to recreate it. Okay, this time validation is succeeded. Perfect. Okay, let's wait. So there are more than one ways to add systems into the load balancer. See, when we go and create VMs, for example, I want to go and create a new VM. And when I do this, I can select all the resource group, and I can give, this is app VM2. This is for my East US app VM2. And I can just go and have some higher sizing. I can just select all these things. So I want to enable IAS on this server as part of the deployment itself. How to do that? Okay, I'm going to allow port 80, that is fine. Okay, but I want to install some specific roles or some specific features, or I want to run some specific script. What are the options available? No answer. So I showed you a couple of options, right? One of them is to either use the extension option, where you can go and use the custom script extension, or you can use the cloud init option. There are more than one option, right? See, please practice, okay? So if you're not practicing, then these things you will not remember. So I showed you, right? I can go and select any script file that is stored in my storage account, and I can go and install it. We also saw how that gets installed, how to check the logs and all those things. So there are more than one ways, but I think I have to create the storage account, upload all those things. I'll go and install it. So here, when I create the VM, if I scroll down, okay, under the networking, if I scroll down, I have the option called load balancing, where I can go and select whether I want to place this machine inside an existing load balancing solution. So that option is within the networking section, and I can go and select this option, yes, and I can select the existing load balancer. I can select the Happy Web Load Balancer 1, and I can say create. So there are two options here. This virtual machine can be part of either Azure Load Balancer, or it can be part of Application Gateway. So as the name suggests, Application Gateway is only used for HTTP, HTTPS web traffic. Whereas if you want to have any kind of traffic, SMTP or any kind of TCP, UDP traffic, if you want to load balance it, you need to use what we call the general load balancer. Okay, so this is mainly for HTTP, HTTPS traffic. I'll show you the lab later. Okay, during the app services class, we'll see the application gateway. Okay, but for now, I'm just going to select which load balancer type, and within that, what is the load balancer I want this VM to be part of. And I also want to select which backend pool it needs to be part of. Okay, I can select this. If there is no backend pool, I can also go and create one and create it. Okay, so this is one option there. How I can go and add the static group listing. Okay, this is one option. Or if I have existing VMs in the same region, because I selected the regional tier, right? If I selected the other global tier, I can go and add VMs from any specific region. Okay, so let this get created. I can also go to the load balancer resource. I can go to the backend pool here. Okay, so if I go to my backend pool on the load balancers, so go to load balancer. Here, I can go and add as many systems as I want. This is the static grouping. Okay, I can add more systems as required. Did I answer your question? Someone asked a question sometime back, right? How to do static management. Okay, so let me go and add another system here. So let me go and create one more VM. Okay, so I don't know what is problem with this VM. Let me try to add this VM now. Load balancers. Select this load balancer. Okay, let me try to see. Okay, it shows me DB only. Yeah. Okay, Magendran. So let me. Okay, this is NIC IP address. Okay, that's fine. Okay, let me see why it is not allowing me. But the database server, it doesn't have a. Okay, we don't need public IP for the backend systems. Okay, only the front end system, only the front end pool needs the. Only the front end needs public IP. Okay, the backend doesn't need any public IP. So possibly I'll go and add the backend system, the private, the database system also. Even though the name suggests it is database server, I'll go and use it as a backend. Okay, so let me go and add that other systems. I can go to the load balancers. I can go to the backend. I can go and add the other system also. So here, if I want to add it to the existing backend pool, what I can do is I can just go to the backend pool here and go and just check the existing backend pool systems. So here, as of now, there are two virtual machines. I can go and add additional virtual machine here. Click on add, and I will say I want to add this DB server. Click on add, and I can save it. Okay, this is how we can do it. You can add as many systems as you want. So now the very first thing that I want to do now is I want to go to each of this resource, quickly enable IAS and enable website on these systems. So in a real-time environment, all the backend systems will have the same exact web page. But for testing the load balancing here, we will go and have some kind of unique identifier to distinguish whether the traffic is going to the same system or different backend system. Okay, that is something we'll quickly explore. So it is taking some time to connect. Meanwhile, I'll connect to the other VMs and try to configure the web page. So which one? So this one I'll connect first. So while I connect, any questions? See, these are all practical things, right? You can also do all these practices on your own so that you feel more comfortable. The more you stay on the Azure portal, the more you can become confident in either attending exams or interview or whatever. Right? I'll also log into the other VM also using the private IP because this VM does not have, oh, it has got public IP also. Interesting. How come it got a public IP? Anyone can help me understand? Any idea? Why? I mean, I did not add public IP for database server, but suddenly I could see a public IP there. Black
So the
magic.
load balancer.
Very good. It's under load balancer now. So once the systems are added to the load balancer, all the systems that are part of the load balancer will start seeing the public IP of this. I mean, you can see the same public IP on all the servers. See, after a few minutes, even this will change there. See, whichever systems I've added to the load balancer, all those systems will start getting the same IP address. See, this is also showing the same load balancer IP, which is 5234. Similarly, this server is also showing the same public IP 5234. So when you add all the systems backend of a load balancer, the public IP will get updated with the load balancer IP. Very good. So that's a very good catch. Okay, so good. So 172.16.3.4. So that's the only thing we did, right? Everything what you're doing, we are doing it together. So that's the way you need to relate it. Sorry, 172.16.3.4. Very good number, but where exactly is the typo? I went at comma. Sorry, guys. Yeah. Okay. While this is logging in, I'll also close this. I'll go and enable the firewall so that it doesn't stop me from accessing the website. Okay, I'll also go and add the roles. So while adding the role, I'm not going to, ideally it should have the same exact web page on all the server, but for identification purpose, I'm just going to give some small changes in each of the system so that I can identify whether my load is getting distributed to different backend system. Okay, let this get enabled here. Similarly, I'll go and do the same here also on the database server. So the name is database server, but ideally I'm going to use that also as a web server in this lab. Okay, let me add the role. Okay, let this get enabled. So once this is installed, you will start seeing a folder under inetpub. Okay, in your C drive, you'll see a new folder. Here you'll have the default page under www route. Okay, I can go and edit it. I will say this is the app server. Okay, so app server 2. Just for my identification, I'm just adding this thing. Okay, so otherwise every server will show the same exact web page, right? So just for my identification, I'm adding a note there. This is part of my app server 2. Okay, let me close this and let me check this server. Here also, I'll go and add some denoter. So this is my DB server 1. Okay, perfect. Now let me go and check whether all these systems which I've added are open to 80 port. Otherwise, the response will not come, right? So I'm on the DB server. Let me check the port network security. So only RDP and 1433 is allowed. So we have not allowed the 80 port. So we need to make sure that we are allowing the HTTP traffic on these systems. Otherwise, the load balancer will not be able to distribute the traffic to the backend. It will show the system is unhealthy because it is not open on 80 port, right? So similarly, I'll check the other two systems also. This one, I guess it's already, no, it is also not open to internet. The HTTP traffic. Okay, similarly, I can just go in. This one we already allowed at the time of creation. Perfect. But we have not changed anything in this machine. So if you want to see the actual IP of this server, you have to go to networking and get the NIC public IP now. After it is added to the load balancer, in order to find the public IP of the system, you need to go to the networking section and find out the actual interface level public IP. Okay, this is app VM2. This is also one of the server part of that load balancer now. Okay, so this machine is now online. Go to server manager. Say yes. So we are just doing the backend systems. We are just enabling 3 servers on the backend and enabling some specific roles here. So ideally, we can just disable the private only. That is what it is involved in this particular setup. But just for quicker reference, I'm just disabling all the public, private, domain, all those things. Let's say next, install. Okay, so once this is done, so all the 3 VMs are now ready. So these are the 3 backend systems, right? We have got 3 systems acting as a backend bowl. Okay, so now I've got an IP for my load balancer. So let me go to load balancers. And I can pick up the name of the load balancer. And this load balancer IP address is the front end IP. So here, this is the IP address. See, if you look at here, this is what we saw on the servers, right? 52 ending with 24. So this IP will be used for representing all the backend systems. We'll also quickly check whether all the 3 backend systems are online. Okay, so yeah, this server is there. This is there. This is there. There are 3 servers now. Very good. And as of now, only these 2 systems are shown as running because the third system is just getting added. Okay, we are just installing the IaaS and the resource status is still not running. Reason is like the IaaS service is not running and so on. It will take some time. So health probe, we have not added health probe. This is very, very important. The reason I say it is important, if I want to monitor the backend systems and report if the systems are not answering on 80 port, I need to have a health probe created. Health probe is to check the alive of the system on TCP port or HTTP port or HTTPS. If I want to only monitor HTTP, I can select HTTP, which will monitor the 80 port. If I want to monitor the secure port 443, I can also select this. Or if I want to monitor some specific SMTP or whatever TCP level traffic, I can enter the port number here. And the backend server will be reported as unhealthy only when the server is down for 10 consecutive seconds. Meaning, see, there is an unhealthy threshold. So there are 2 consecutive failures, and each failure should last for 5 seconds. Only if the machine is not available for continuous 10 seconds, it will be marked as unhealthy, because some systems might have some network challenges, or some locations or some regions might experience some smaller network glitches. So it should not go and turn the machine as unhealthy, right? So I'll add a health probe, happy health probe 1. You can also change it. Okay, you can change the consecutive failures. You can increase and decrease the threshold if you are seeing a lot of issues. But in cloud, we don't have to worry too much. In on-premises, we generally need to think about this little more deeper, because, like, for example, some remote locations or some sites in Africa, they are all mostly unstable in the network level. So we might have to have a increased interval or increased threshold to make sure that the health probe is not reporting unhealthy very frequently. Okay, unhealthy status frequently. Okay, so once the health probe is added, we can go and add a rule which can attach this health probe to the specific traffic. For example, now I've got a front end and I've got 3 backend systems and I've got 1 health probe. I need to attach all these 3 things together. How to attach all these things is to create a rule for associating these 3 components together. Okay, so go to the load balancing rules here, click on add. I have to select, this is the happy load balancer rule 1, and we have to select which front end I'm going to choose, which backend I'm going to choose, and which health probe I want to attach to it. So these are the 3 things I am just kind of attaching it together. So here, if I look at the rule, okay, it is asking whether I want to use a different port, or whether I want to have different ports in the front end and back end. But I don't want to make any changes for now. If you want to secure your traffic, you can use a different front end and back end port. The front end will listen on some specific port, and the back end can be communicated on the default port or some random port. This will help you to enhance the port level security. Okay, here I have to select which health probe I want to use for monitoring the traffic. To monitor the 80 port traffic, which health probe I want to use? I want to use this health probe. So simple thing, I'm attaching the 3 things together: the front end, the back end, and the health probe together. And one more important thing in this particular list is the session persistence. Session persistence, as I told you, Microsoft load balancer, Azure load balancer works on 5-tuple algorithm. So how the session persistence can make use of this 5-tuple algorithm? For example, I'm a user 1, okay, and I'm connected to a specific application, and I'm filling a form, or I'm just completing some work on a particular application. So if there is a network disconnect between the source and the destination, and when I'm connected back to the network, and if I connect to the load balancer or the application, what will happen in general? I might be connected to server 2 earlier. Now I might get connected to server 3. If I get connected to server 3, whatever information I started filling in, or whatever work I was doing on server 2, it will not have the same level of content on server 3, because the session will get, only after you save the application, it will go and save on the backend. Otherwise, if the work was interrupted in between, then there is no way that you can continue the work, right? So in order to provide you that session persistence, or in order to provide you the continuity of what you are doing, Microsoft has given you the affinity option, where if the user is connecting again to the application from the same client IP and the client port, I can just connect it to the same server again. See, you have 2 options here. Either I can create the session affinity based on client IP. If all the users are connecting from the same office environment, mostly all the users might have the same backend IP, right? So for them, it's a kind of group of IP. So if I want to allow specific traffic based on the client IP and port, it will be much better. It will check both the client IP and the port, and it will make you connect to the backend system. So only thing is, if you enable session persistence, it might slightly delay the traffic, but it gives you advantage of connecting back to the same server and start continuing the work that you have been doing before the outage, network outage or the server outage, whatever, right? So it will help you to do that. So as I told you, you can enable TCP reset if the systems are down or if the connection is kind of not actively used. You can go and do a reset. Okay, let's complete this part. We are already 10:50, so we'll take a quick break after the lab. And there is few more things that we need to discuss on load balancing. Okay, let's see the output and let's go for the short break. Any questions from anyone so far? So rule is to attach the list of systems together. So the rule will go and attach this front end should go to this back end, and it should use this health probe to validate the back end systems, whether it is healthy or unhealthy, and report it to the load balancer. Okay, now we have the
Stan,
This is
without rule, health probe will not usable, or what is that?
yeah, health probe should be attached to the rule. I mean, to the front end and back end. Without that, yeah, we are not going to. I mean, it's just creating of some configuration without attaching it. So you have created a network interface, but if you're not attaching that network interface to that system, or if you have created a disk and if you're not mounted it or attached to that system, it is not at all usable, right? That's the way it is.
Yeah. Oh, okay, okay. So we need to create rule and we have to include it in the
Correct.
rule.
You need to
Okay.
include that rule to verify which port we need to monitor and so on. So I'll just
Okay.
go ahead. What is the question? Someone also started talking.
Yes, Stan.
This application VM2.
So Azure Load Balancer is always active, or it also can do active passive, right?
It's active only. Load balancers are active. The backend clustering concept, see the database clusters and the failover, it makes sense to create active, passive, and so on. See, web server, the front ends are always are mostly active. There is no reason to have them active, passive in majority of the case, because like if you are having idle backend web servers, what exactly you are going to achieve with that? But if you're if the backend clustering or the server cluster or the failover clustering concept, there is a logic behind it, because not all the cluster options support active. We might have to also choose active passive in some cases. Maybe one server is on very high capacity, the other server is low capacity, and so on. But in front end load balancers like what we are discussing now, it's mostly all active only, 99% of the cases.
Okay, good.
Yeah. So let me copy the IP now, and let's go and check the load balancer. Now we should start seeing the IP address, web page going to different systems. So if I refresh, or if I go and use different browsers, I should start seeing different IP address. I'm putting the IP address on the chat, so you guys can try out from your side and let me know like whether you guys are getting different page or you are getting the same page. I can open up a new incognito window in my machine also here.
I get DS.
Yeah, it's going to DS1. Yeah, same here.
Campus.
I'm opening up one more attendee. Other attendees also saying the same. They are also getting DS1. So I opened up an incognito window, and I'm using the same IP. The same IP is going to one server, and the other request is going to another server. And now I'm going
getting
to
DS1.
try DS1, right? Okay, so different people getting different systems, which is good. Okay, so yeah, the load balancer is now distributing traffic to different systems on the back end, and see, it is going to AVM2. Very nice. So so that's the load balancer, right? The users will be connecting to the particular IP address or the FQDN, but their request will be redirected to multiple backend system based on the number of users hitting it, or based on the amount of load. right? It's majorly to distribute the traffic. So just for identification purpose, I'm having different identification here. Otherwise, in real time, all the backend systems will have the same exact page, and you'll be seeing the same exact form and all those things. Okay, with that, we'll go for a short, quick break and come back. Okay, and any questions? I'm here for 2 more minutes before I open up the break. Okay, if not, let's go and take the tea break and come back. I'll stop the recording.
This conference will now be recorded.
Yeah, so before the break, we saw the practical for the load balancing. So on a very high level, you understood, right? If you have a web application or an application service that needs to be highly available, we generally go and create a group of systems that will form the cluster, right? It's a group of systems that will be there for an application. And if you want to distribute the traffic to all these backend systems, you need a load balancer in between, right? That load balancer purpose is to distribute the traffic to the backend systems based on the usage, based on the current utilization. Okay, so now let's take one another scenario, and let's talk about a little more advanced concept within this load balancer. Okay, 1 second. We started this recording, right? Yeah. So now people think that load balancers can only be used for the application level traffic. It's not the case. Whatever we are talking about, it's a network load balancer, right? We can use it for any protocol, especially the load balancer that we are now discussing about can be used for any purpose. Meaning you can also use it for distributing traffic on SMTP or whatever TCP UDP port that you would like to transmit. Right, so load balancer doesn't directly interact with UDP or application layer or TCP. It can be used for any scenarios, okay? Any application scenario, or it can be used for terminating any request or any particular handshake. See, I just generally give an example on the advanced load balancer concept, where you can also merge NATing and patting together. So NAT, just now I explained, right? What is the difference between source NAT, DNAT, and all those concepts? So patting is very much similar, but it is at the port level, port address translation. When we created a rule, we got the option to select which source port you want to use and which backend port you want to use for your system, so that you can allow, you can disallow people from getting the actual port numbers and getting inside the system. So we can have a backend different port, and front end can be in a different port. So all those things can be done. But besides that, you can also merge NATing and patting and implement different solution. See, for example, we had a requirement a few months back where we had a customer where they've created multiple gem servers. Okay, gem server 1, 2, and 3, and so on. And what they want to do is they want to use specific gem server for specific support teams. Okay, so they've got multiple gem server, and out of which they want to group these 6 or 7 gem servers into a specific requirement. For example, the first 2 gem servers, they started using it for VMware and some specific Intel group, and the second set they started using it for some Citrix and virtual desktop support groups, and so on. And similarly, the others they used for some different support group development and for some programming needs and for database support and so on. So they want to have the gem servers with some specific requirement. For example, the VMware or the Citrix server will have the prerequisite for the Citrix receiver or the .NET framework or Java plugin or the Java runtime environment. So all those things specifically needed for that specific support group to support the environment will be loaded on these servers. And when the Citrix user connects or when the Citrix support team connects, even though they will be hitting the same IP address, they will be redirected to the gem server that has got the specific application loaded on it. Similarly, the VMware team or the Intel support team, when they log in, they will be redirected to the system where I've got their necessary tools. Similarly, Linux and other support group. There will be different support group. They will be logging into the gem server with one same IP, but they will be connected to different gem servers on the back end, which has got their necessary tools loaded. Okay, for example, let me give you a quick example here. So I've got this server, right? What is the server? So this is my app server, right? So what I'll do is, I'll just for an example, just to understand this thing quickly, I'm creating something on the desktop. So this is mainly for Citrix VDI. So assume there is an application that is installed on this server. Okay, just for identification purpose, I'm just adding something here. Okay, so let me cancel the shortcut. I'll add some bitmap image, Citrix apps. Okay, something like that. And on the other server, like we have connected to other server also, right? So on this server, I'm going to add something on the system. Okay, this is the database server, and I will say, so this has got the server management studio or whatever that is loaded. Okay, tool or whatever. This is for the SQL management, or I've installed some applications on this particular system. Okay, so this is my DB applications. Okay, so now I've got different applications loaded on these different jump servers or terminal servers. I want to have the traffic distributed to the backend systems based on the request. For example, okay, I've got the load balancer now, and on the load balancer, I have the option to go and configure inbound NAT rules or load balancing rules. So here, if I go and create this inbound NAT rules, I have got multiple options to play around here. So I'll say this is for what is that? DB support group. Okay, for DB support group, I have installed the different tools that is needed for the database support team to manage the environment. So on the back end, I want the traffic to go to only the database server. And similarly, if there are multiple network IP address configuration on that system, I can distribute to different IP address configuration, but it is only one. On the front end, I want to, whenever the users hits the front end, if they hit this particular front end IP, their request will be redirected to this backend server and this particular backend interface. Okay, I can have more than one particular server on the backend. So if they are connecting on this port, for example, let me pick up a random port. I'll say 555 or whatever number. Okay, so generally the port number is RDP number is 3389, right? I will say this is 888 or 48s, and I want to use it for a specific service, whether I want to use it for a database or whether I want to use it for SMTP or FTP or MySQL or whatever. I can use it for any TCP UDP protocol. So here I'm going to use an example of RDP, and the backend, if I have changed the port on the system, for example, you can go and change the RDP port number inside the registry, right? If I have changed that, then I can give that number here, or else I can continue to give the default port number here. Okay, the backend port is also 3389. Okay, the front end port is 888 or 48. Okay, and let me go and okay, timeout is fine, TCP is fine, and this should be okay. Let me add this inbound rule. Okay. So now I'm also doing a port address translation here, not just the front end to back end IP address, also not at the network level alone, even the port is getting translated here. So I'm submitting a request and I'm just adding a NAT rule. I'll also go and add one more rule for VDI support or Citrix support so that they can connect to the jump server, which has got their own tools loaded. And if there are some common group which doesn't really require tools and stuff, they just need the jump server to log into the environment, they can pick up anything and they can log in and start using it. Okay, so that's the kind of floating users who will connect to the jump server just to manage the environment. They don't need any specific tools and so on. Okay, I don't know why there should be. Okay, let me add one more rule for the VDI support or the Citrix support or whatever. They will connect to the app VM. They will connect to this interface. They will hit the same front end IP. The port number they might use is 49, and I'll use the RDP. So always make sure that when you select the service tag, this will get reset. Okay, so because like we are selecting the service tag as RDP, automatically this will get reset. So make sure you are changing it again to reflect the number that you want to use, and I can say add. So after these two NAT rules are added, or the NAT plus PAT rules are added, when you go and hit this public IP, okay, if I go and hit this public IP in RDP, I have to use the specific port number there. 52, 191, 23.24. If I just say 888 or what 48s, it will automatically take me to which server? Which server? Am I audible?
Yeah, the app server, right?
No, the DB server, right? The database server. Yeah, ideally like whatever we have configured, that server, right? So if I click OK, even the certificate will clarify you what it is connecting to. See, it is connecting to HPY DB server 01. Right, if I log in, it will go and see the what do we call whatever the database thing that we have created, installed and configured. See the SMS server management studio, the DB application, and so on. Similarly, if I go and use the same IP and use port number 49s, my machine is getting slow. Okay, sorry. If I use the same thing and using 49s, I don't know why it's resetting. There is too much of cache created in my system. I might have to restart or refresh. 23, 24, 49s. Now it should go to my VDI server or VDI jump server. So ideally, different support units might have different requirement. In order to handle that particular ask, you can deal it in load balancer level also. So the simple thing that I want you guys to understand, people think load balancer is just to load balance the HTTP and HTTPS traffic, not that. Okay, application gateway is specifically for distributing application traffic, but these load balancers can be used for any different use cases. See, it is going and connecting to the app VM2, which has got all the VDI and all those Citrix related applications loaded for the support team to support it. So it will connect to the same server. See, Citrix VDI, Citrix apps, and so on. Clear? So think about load balancer as a kind of a device or a appliance that distributes traffic to multiple backend systems based on NAT logic as well as PAT logic. Clear? Any questions so far? Yeah, sometimes we get to discuss little more advanced things just for people to understand the concept. Okay, so when you practice these things, you get to understand it a little more deeper. But on a theoretical level, what we have discussed about what exactly the load balancer is used for, and what are the different SKU, or what are the different type we have got, the standard SKU and the basic SKU, and what kind of algorithm it uses to verify the hash and then distribute the traffic. And also we discussed about the different things that are involved, the front end, back end, the health probe, and the rules, right? Okay, what else? Okay, so these are the things that are involved. Any questions from anyone before we move on to the next topic, DNS zone?
Stan, can you provide the range of ports to the particular application? Range of ports.
No, see, if this is not IP address, right? A port is a port. See, for example, if you're talking about responding the answer in a range of ephemeral ports, that works by default. You need not mention it. But if you want to access a system